All right, let's have a look at adding algebraic expressions. It's fairly straightforward. It follows the same principles as adding just general fractions. In that, the idea is to make sure that the denominators of both fractions are the same. And so, because they're not, we have to find the lowest common multiple of these two fractions. So, the lowest common multiple of 9 and 3 would be 9. And so, if we're looking at this second fraction here, and we're looking at the denominator, what would we need to do to multiply 3 to make it into 9? And so, essentially, it's 3 times what equals 9, and that's 3. To keep this fraction equivalent, we'd have to multiply the numerator as well. And so rewriting this, you'd get 8x over 9, add 6x over 9. And so now that your denominators are the same, you just add the numerators together and write the denominator as just 1. So 8x, 14x, because we're just adding the numerators, over 9. So fairly straightforward, that one. Our second example is a little bit trickier. The reason why is because we've now got two-term expressions, both on our denominator and numerator. So let's have a look at how we do this. Looking to see if our denominators are the same. No, they're not. X plus 3 is not the same as x minus 2. And so it's a bit hard to find out the lowest common multiple of these two terms. I can't do it in my head, and I don't expect you to be able to do that either. So the next best thing, I suppose I call this plan B, is to just multiply these two terms by each other. And that'll give us a multiple. It might not be the lowest multiple, common multiple, but it's going to be a common multiple. So let's go ahead and do that. And this is how we set it out. So we'll write that first fraction again. So x plus 5 over x plus 3. But we're now going to multiply this x plus 3 by that second fraction. So let's make sure that this is all in brackets. I might even use no, I'll go with the same color. So x minus 2. All right, let's extend that fraction line. And remember, whatever we do to the bottom of a fraction, we must do to the top. So we'll multiply the top here by x minus 2 as well. Minus x minus 1 over x minus 2. And now we're going to multiply this denominator by the first fraction denominator. So it will be multiplied by x plus 3. Whoops, let's fix that up. And whatever you do to the bottom of a fraction, you must do to the top. So we'll extend that fraction line and we'll go multiplied by x plus 3. So if we put brackets around everything, just to keep it consistent, now you can see that our denominators are the same. So we can go ahead and actually subtract the second fraction or the second numerator from our first numerator. So it'll be x plus 5 multiplied by x minus 2, subtract x minus 1 multiplied by x plus 3. In order to actually achieve this, we're going to have to expand those brackets out. What I might do is I might just shift this whole expression up a little bit, just to have some more room. So what we need to do is actually need to expand. We need to expand this expression here on the numerator, and we'll also need to expand this expression here on the numerator as well. After we've expanded, we can then collect some like terms, and then we can simplify. All right, so going back to how to expand brackets, the acronym that we use, and I'll write it, say here, is FOIL. Stands for firsts, outers, inners, and lasts. That's an acronym for what terms we multiply together and when. So we always start off with multiplying the first terms on each bracket. So x times x, that'll be x squared. The inners on each, 5 times x, that's 5x. The outers, x times minus 2 is minus 2x. And the lasts, the 5 and the negative 2. So 5 times negative 2, or minus 2, that's minus 10. All right, let's subtract that now. And so as you can see, all I'm doing is writing my numerator. So we'll go across to this, or these lots of brackets. We'll go ahead and expand them now. All right, so looking at the firsts, it'll be the firsts here. So x times x. Again, that's x squared. X squared. Next is our outers. X times positive 3 is positive 3x. We have inners. Negative 1 times x is negative x. And our lasts is our negative 1, negative 1 times positive 3, which is negative 3. Okay, what I'm going to go ahead and do now is I'm going to write this all under our common denominator. And you can actually choose whether you want to write this as your common denominator or this. They're both the same, they're just in reverse order. So I'll just go ahead and write the first one, which was x plus 3 multiplied by x minus 2. So our denominator is complete. It's just our numerator that needs work on. What I want to do is just focus your attention on this subtract or this minus sign. This minus sign, which has gone down here, that's actually subtracting this entire expression here. So here's what you can do. You could, if you're taking away positive 3x, you could actually reverse that positive sign and make it a negative sign. If you're taking away negative x, well, that's also the same as adding, because a negative and a negative makes a positive. So I just want you to keep in mind that when we start collecting these like terms, this negative is actually being applied to this term, this term, this term, and this term. I'll remind you again, but just keep that in mind. All right, so now what we can start doing is collecting our like terms. In fact, what we could do before we even start collecting our like terms, we could just have a look at our first expression here, see if we can simplify that, and then have a look at our second expression and simplify that, because it looks like we could actually simplify them even further. Because I can see positive 5x take 2x, or negative 2x, and plus 5x or positive 5x take away 2x is going to be positive 3x. So what I will do, is I will simplify this even further. So x squared positive 3x minus 10, and I'm going to take away x squared, and here we have 3x minus x, that's 2x, so plus 2x minus 3. And remember, that's all over x plus 3 multiplied by x minus 2. Let's keep going. So now I can start collecting my like terms. So I've got x squared minus x squared. Well, that's just 0. So what I can do is I can go ahead and get rid of my x squared here and my x squared there. I now have 3x take away positive 2x. So a negative and a positive will make a negative, right? So it's 3x take away 2x, and that's just x. So let's go ahead and write this. We'll start writing out our answer. So x. Now we have negative 10 take away negative 3. If I were to write that in isolation, let's write that just up in the top corner here. Negative 10 take away negative 3. These two negatives become a positive. Whenever you combine two negatives together, they become a positive. So it's the same as writing negative 10 plus 3. And when you have negative 10 and you want to add 3 to that, well, that's going to become negative 7. So it's going to be x negative 7 over, let's use a straight line, over x plus 3 multiplied by x minus 2.